Let's get started. We'll be going through the creation of this project from scratch so you can see exactly how simple it is to get started with TimelinePI. So I'll begin by pointing out to my claims events file. This data reflects all of the events which have occurred as a part of an insurance provider's auto claims processing and would be sourced from their claims management systems. Now, the tool has recognized the previous mappings for this file for convenience sake. The important thing to note here is there are just three fields which are required in order to get started. The first field we'll want is a timestamp field, which is simply going to tell us when an event has occurred. Next, we'll need an ID field, which is going to allow us to join together all of the events in a given claim instance into the same context. So in this scenario, we'll think of using something like a claim ID, but this could be anything from a policy ID, a customer ID, or any type of unique identifier which signifies what we're looking to measure. Now lastly, we're going to need a field which tells us what happened at that step, the event name. This is going to tell us the work that was completed. And for this example, we'll see things like the first notice of loss was submitted, an adjuster was assigned to a claim, initial review has begun, and so on. Now, those are the only three required fields we'll need. And lastly, you can see some of the other fields that we have mapped here in purple. So we can bring in additional fields which you may consider to be dimensions or ways that you want to slice and dice or break down, filter the data by. So for this example, we'll use fields like the adjuster on the claim, the state that it was submitted in, the policy type, priority, claim amount, and so on. Now, finally, it's worth mentioning that these timelines can be assembled from multiple files corresponding to different systems of record, so different events can come from totally separate data sources. As long as all of these data sources contain the same object identifier, the tool will be able to connect them together and insert the corresponding events into the correct timelines. So we've mapped some columns in this file, and what we do is simply hit load and allow the tool to begin reconstituting the process based on these events. For this demonstration, I've already loaded this data, so I won't waste our time doing that. But if I had, it would have taken about 90 seconds to load what we have here, which is more than 500,000 events related to our claims. In that time, the tool is going to reverse engineer the process, build out all the models, run statistics, and create the multiple forms of analysis that we'll be going through. Once we've successfully loaded the data, we're then presented with the overview page, which includes quite a few metrics which are going to give us a better understanding about our project and the data that we've uploaded. The first thing I want to point your attention to is that almost 550,000 events which were loaded have been mapped into roughly 31,600 timelines, or in this case, a timeline is going to be synonymous with a claim. We pulled out 31 different types of events from that data, and if I pop those up, we can see all of our events listed. I can sort them by the most commonly occurring events, or those associated with the most amount of timelines or claims. Now, the other thing to mention here is that I've assigned a few icons to be used as opposed to the default gray circle with a number in the middle. This allows users to quickly identify specific events or critical touch points in the workflow, and you'll see that this will become more important as we move on to our timeline analysis view. Now, if I pop up my icons, you can choose to use your own icons, you can use the icons we provide, or simply use coloring to make different events stand out. So that's all that we've done. Everything else that I show from here on out is automatically completed by the technology. So we've got some metrics which have been automatically calculated from the data, as well as the many different analysis apps which we'll touch on to the right. Now, the metrics include the average duration of our claims process, along with the total range. So on average, it takes us 23 days to close out a claim, but it can range anywhere from 6 hours to 15 months. The number of events in a given claim instance, along with the unique count of events, because of course events can be duplicated or done multiple times as a part of a single claim. We've also got the time gap. This would be the delta of time in between any two events where essentially no work was being done on a given claim, and this will become a little bit more obvious when we get into the timelines view. Lastly, we've got the distribution of the first and last events in our process. So essentially, which events are most commonly starting and ending this claims process. So from here, let's quickly move to the timelines view and take a look at the actual process path which the tool has generated. In looking at the timelines analysis, we've got all the different claims timelines here in the center of the screen. Each of the different horizontal lines with the circles on them represents a separate claim, and each circle represents an event or a step in that process. And you see I can mouse over and get more details on these events. Now the length of each timeline is proportionate to the elapsed time, so of course some are going to be longer than others, and this includes those gaps in between steps where no work is being completed on a claim. So by clicking on any one of these gives me much more detail as to what's happened with this specific claim, in what order and at what time, along with those time gaps. So this screen is showing me details specific to timeline or claim number X. Now the column is showing me the superset of all the events which have occurred as a part of this claim. We can see when first notice of loss has occurred, when coverage and liability is confirmed, an adjuster is assigned, and so on. Now, if I turn on the sub-processes, what's going to happen here is these additional columns to the right, the tool has automatically figured out by analyzing specific patterns in this data set as to which things are most commonly done together or as mutually exclusive steps. So in other words, it automatically detected those which are done as sub or parallel processes and has grouped them out together. So for example, every claim should expect to have a first notice of loss event along with a coverage confirmation and a fraud check, but not every claim is going to have a personal injury claim associated with it, maybe a rental car or total loss with corresponding salvage information. And you can see those broken out here and grouped together as sub-processes. So in essence, you'll see events grouped together which correspond with the major categories of the insurance claim: coverage, liability, damages, subrogation, and salvage where it applies. Now this is very much a micro view of the process as opposed to that main timeline screen, which at first is a macro view. But the granularity that we have here can oftentimes be very useful. If we're looking to uncover the root cause of a compliance risk or a workflow inefficiency, we no longer need to physically walk around with a clipboard and stopwatch and try to spot what is very often a needle in a haystack. The level of detail that you have here tells the entire story about this claim, and at the very least can give you clues as to where the problems lie, if there are any. So if we think about loading up data across multiple systems of record, we're essentially piecing together the composite life cycle of this claim throughout the entire process, regardless of the system of record which is responsible for recording these events. So if I close this out, we can see here that there's a huge amount of variability in this process. And after having looked through this data, I can tell you there are no two timelines which are chronologically exactly the same. So you might ask if there's some sort of way to map a process diagram that's going to generally explain how claims are going through our process. And in reality, this is a question that most businesses will struggle to answer with their existing technology set, and is a big reason why a lot of people can't tell you with a high amount of confidence exactly how their processes are being executed. The process schema editor gives us the capability to visually map that most common path through the process. And we can first do that by allowing the software to take what it believes to be the most important milestone events. So when I click Select Default Milestones, what's happening here is the tool is using advanced statistical analysis, specifically picking the events which are most reliably and commonly occurring at the same point in our process. So it looks like it picked 10 events as milestones, which is great. We can always customize this, so I have some others I'd like to assign here. Let's include in this model where claims are being denied, where estimates are being prepared, and maybe where fraud checks are being done. So now I've added a few more events. Let's have it generate the schema for us. So this is showing us that most common schema or path based on the milestones that essentially I said I care about. Okay, so we can see how claims are flowing through our process. And the nice thing is that this is not just a static Visio diagram. When I choose to save this, it now becomes a monitoring tool. It's telling me the number of cases, and you can see that via the thickness of the line, the number of claims which have gone one transition relative to another, and I can mouse over and see the number of transitions, which is a more common path versus others. Or if I want to look at this based not on the volume of claims which have gone one transition versus another, but based on the amount of time spent in the process, I can change the metric here and allow the line thickness to now represent the amount of time we're spending in certain areas of our workflow. Okay, so we can see what the average duration is between one step or another, and where are we spending the bulk of our time, where are claims possibly backing up due to the amount of time being spent in certain areas. All right. And we can take this even a step further and start to animate this diagram and visualize the claims as they flow through our process. So when I turn this on, what we're going to see is all of the circles are going to go through. Each one of these represents a claim or a group of claims. We're going to see when things start to bunch up or bottleneck. Essentially, as things are changing color, they're actually aging and spending more time in the process. Now I pause the animation. If anything stands out as something that doesn't look quite right, for instance, this one single claim that's up here right around the processor assigned event, I can actually click on this to get much more detail as to specifically is what happened with this claim, what happened in what order, what's going on, and who was associated with it, so that I can drill a bit further if I'm interested. But the idea here is that we can get a very, very quick look at where claims are starting to slow down, back up, age within our process, and where things are grouping up and starting to bottleneck, right? And we can start to focus on these areas to improve our overall efficiencies. So now that we have a much better idea of how claims are generally moving through our workflow, let's go back and take a look at one of the other process discovery mechanisms, which is going to highlight the amount of variability in this claims process. Let's try to put this in a way which is easier to begin analyzing. So those interested in Lean, Six Sigma, really anybody concerned with continuous improvement often will like this type of view of the data. What this is a frequency distribution of all of my process paths with the most commonly followed behavior showing up here towards the left. Now this is clearly going to expose when steps have been skipped over, done repeatedly, or totally out of order, with the most common behaviors highlighted here for us. So what we have is our events here along the left. Along the top, we've got the number of claims which have gone one path versus another, and it's going to be descending. But as you scroll to the right, you're going to see any number of interesting and obscure paths where things are bouncing around, not completing steps, not going all the way through the process as we would expect. So it looks like 1,704, or only 5.4% of our claims, are completing a quote-unquote straight-through process, and there are many different variations to how this process is being completed. And one other thing to mention here is we've got another metric along the top, which is our average duration. So we can actually start to compare how long it's taking us to complete one execution path versus another, and obviously we can start to drive towards not only a more compliant form of completing this claims process, but a more efficient process from a timing perspective, right? So that our throughput comes into focus and we can make sure we do everything in a timely manner. We have the ability to actually change this metric and take this a step further. So if I don't want to look at this by my average duration, but instead by the cost of each one of these execution paths, I have this metric available to me. So now I can start to focus a bit more on the bottom line and say, this is the amount it costs us when we go the straight through path. There's some other variances when we execute other behaviors. Obviously, this one that's $208 versus the $110 is not ideal. We want to hone in on this and figure out exactly what's happening here, who is executing these specific claims, and try to push them towards the more efficient, from a cost perspective, execution path for these claims, right? But we can now compare all of our different process paths and see where the costs are being incurred and where our bottom line is being affected, from a large perspective. Okay. Now, if there's something that stands out here as, this shouldn't be occurring, or a safety risk or a compliance issue, we have the ability to really drill in on that very, very quickly. So let's say this coverage confirmation step, we expect that should always be happening no matter what. And if it's skipped, this is going to be a non-compliant claim. And what we can do is we can set a filter that says exclude timelines with this activity, right? So we're going to look at all the claims that have not had a coverage confirmation step, essentially. And when I set that filter, it actually shows me there are quite a few different paths where we haven't completed a coverage confirmation, and it looks like gone on to complete subsequent parts of the process, which would be a huge red flag in the insurance business. Now we can again drill a bit further into these specific instances, start to uncover root cause. Where can we start to focus our efforts to remediate this and make sure we put the protocols into place to make sure we're not skipping that coverage confirmation step and processing unconfirmed claims. So that filtering of the data that I've just done will become a theme you'll see as we go. We'll start with our large data set and begin to whittle it down to more manageable sizes based on conditions that we build in, or sometimes just let the tool do the analysis on its own to try to uncover the interesting things that are happening within our workflows. Now, the last aspect to mention about this path analysis is we actually have the ability to not look at this from an arrow-based perspective, but look at it via the schema. So we can include the actual process schemas as a part of this frequency distribution and start to visualize exactly where things are going from a schema visualization perspective, giving us maybe a more graphical look at exactly how each of these paths are being executed. In working with the full data set, it's helpful to use the metrics along the top to start to get a better understanding of our data as opposed to scrolling through all 31,000 cases. These metrics are always going to be representative of the set of timelines which we have in the window below, and we'll see these recalculate and change dynamically as we filter and scope our analysis. So right now we're looking across all 31,000 plus claims, and in looking at the duration metric, the fact that there was at least one case which took 15 months to complete stands out. Let's dig further into this and figure out exactly how long it's taking us to close out these claims. So by clicking on the duration metric, I'm then presented with a histogram which shows me the distribution of all of my claims by their duration. I can see that the minimum time to close out a claim is 6 hours, the average closeout time is 23 days, and the maximum is over 15 months. Now, in looking at the histogram, fortunately we have a spike towards the beginning, which shows me most of the cases are done in far less than 15 months. I can adjust this slider dynamically and start to get an idea of how many cases fall above or below the threshold that I've set. So I've set the slider to 42 days and we've captured almost 94% of the cases, but there are over 1,900 outliers, or 6% of claims that range between 42 days and 15 months. Now what's interesting here is that I can take this a step further and choose to break this histogram down by any one of my dimensions. So if I'm concerned that there may be an adjuster who's taking their time with these claims, or even a type of claim which is taking abnormally long, I can sub any one of my attributes in here into the main histogram and start to dig in. So let's break this down by the adjuster. And now each one of my respective adjusters has their own duration histogram relative to their book of business. Now, if I take a look and just visually identify which one of these stands out from the others, it looks like Jim Ricks. His histogram is skewed a bit to the right. So keep your eye on my general average here. It's 23 days. Now, when I substitute Jim Ricks' histogram in, it looks like Jim takes 2 months longer than my general average to process his claims. Now, this tells me it might be time to have a conversation with Jim to see exactly what's going on and why it's taking him so long to close out the claims he's assigned. So let's close out Jim's histogram. I'll go back to the general histogram, set my threshold at 42 days. As an analyst, I'd be interested in digging a bit deeper into these 1,942 claims that span longer than 42 days. So I'll apply this as a filter. Now we're looking at only those 1,900 plus cases which span longer than 42 days, and one thing that many organizations are concerned with is making sure that they get all the necessary information from the customer or third party as quickly and as expeditiously as possible. If you fail to get a certain piece of data or a document, we then need to go back to the customer to request it, and that isn't always completed in a timely manner. Each time this occurs, we're elongating the claim itself and causing more and more friction from the end customer perspective. So I'll click on my requirement for more information step, and then I'm shown a histogram and all the details as to how often this requirement for more information is done as a part of these claims. So I can scroll this threshold to the right, maybe dig a bit deeper and only drill in and look at the claims that have 3 or 4 requirement for more information events. But I want to get a bit more quantitative about this and see exactly how much time it's costing us each time we go back to the customer. And we can do that using the time interval measurement tool. So I'll bring that up. And what we're looking at here is the starting event is a requirement for more info, and the ending event is that the additional info has been received. So exactly how much time goes in between these two events and is being added to these claims because we don't possess all the pertinent info. As always, we show you the minimum, the maximum, and the average values as well as the distribution. So while the minimum time in these longer cases is 5 hours, the average amount of time it takes to receive the information is 4 days, and the maximum time being almost 54 days. This would be quite a long time for a claim to sit with no work being done on it. And to make matters worse, from what we saw in this events histogram, this could be occurring up to 4 times in any given timeline. Now, if we want to drill in and try to understand maybe more about the root cause, if there are trends in the data that are going to lend us to see where these types of long claims are happening, we can further break this subset of claims down by any attribute to see if these delays are related to a particular type of claim or if they may be a human element, for instance, an agent or adjuster, who are most commonly handling these longer claims. So let's go to our breakdown application, and I'll just show you. We can choose any one of our attributes. So the person responsible for receiving the information from the customer is actually the agent. So let's break this down by the agent. And what I can see is Carrie Ann McDonough stands out. She's accountable for almost 40% or 712 of the 1942 longer cases. Again, it would make sense to go and have a conversation with Carrie Ann to see if there's possibly a training or a procedural issue which can help us to avoid these claims from spanning so long. What I can do if I want to drill even further into this is click on Carrie Ann's name, apply her as a filter, and drill into the exact timelines or claims that she's been associated with. Search or query is hugely important. Now, while traditional BI search looks for objects by using their current attributes, what if we're interested in looking at things from more of a historical or a pattern-based perspective? For instance, if someone wants to know how often a certain scenario is happening, we've got rental cards being issued on claims without any record of a coverage confirmation step, and then subsequently the claim is denied after the organization's already incurred the cost of the rental car. It seems like something that probably shouldn't happen, but by only using BI search, we'd have a very difficult, if not impossible, time answering that question. So you'll see I'll visually build out a query that explains that scenario. So we've got a coverage confirmation step, followed by a rental car being issued on the claim, and then subsequently the claim was denied. But in this scenario, we've missed this coverage confirmation step. So you'll see that this has not happened, yet we've issued the rental car and the claim was then denied. Now, if I click search, I get a very quick response time and can see actually with 91 claim instances, we've skipped the coverage confirmation, issued a rental car, and had the claim come back as being denied. And that was done extremely quickly and easily. Now, the beauty of these queries is they don't need to be trivial either. So we can specify a number of other options from time constraints, the number of repetitions, or use specific values based on our attributes. So we'll add to this scenario that the rental car was returned after we sent the denial notice, but the time period between when the claim denial was sent and the rental car returned was greater than 4 days. So we'll say the claimant decided to take their time before they brought the car back, again driving up the total cost of this claim. So you can see we can build time in very granularly between any of the given steps in this query. Now I've just added to that, I click search, and I can see actually in 44 different claims, the claimant decided to take their time bringing the car back greater than 4 days. Now, the ability to go off and explore and test a hypothesis like this is obviously pretty powerful. But another aspect of these queries is that you can set them up to trigger alerts. So we don't need to be sitting and babysitting this data all day long. We can configure alerts to fire off when conditions are met, making people aware that these specific cases are occurring, essentially building another level of accountability into our process. As we get into more specialized forms of asking questions, we can look at the protocol analysis. A good example of a protocol is in financial services. When someone applies for a consumer loan, they have to get certain disclosures and good faith estimates. Things that the government requires are taken into account. These things are mandated and absolutely must be done the prescribed way, otherwise, you're in violation of federal law. Likewise, most processes include areas where when we get to a certain point, there are certain things that absolutely must happen, and oftentimes within a given time range. Now, in comparison to a query which says, give me all the cases that match the condition I've created, protocols allow users to define a set of rules which should always be followed and will show the timelines which violate that rule. In other words, it will be the inverse of a query in that it shows the timelines which don't match the condition that I've set forth. Now we've got a simple salvage protocol that I put together here, which says that when a vehicle is confirmed as a total loss, we want to make sure that it's salvaged in a timely manner, less than 10 days, because each day that it sits on the lot, it's essentially a depreciating asset. So if you go through this protocol, the estimate's prepared, it's approved, we've confirmed it as a total loss, we want to ensure that within 10 days, we've salvaged that vehicle. Now, as opposed to only looking at new data being loaded into the system, we can also use these protocols for analysis on our historical data. So if I click Show Violations, here is not only that our protocol was violated, but also a description of how it was violated. So we can see things like the estimate approved was in the wrong position. We've got a time violation about the constraint we built. Some things are missing. And one big consideration here is to not flood someone with false positives. So if there are certain things that are not of interest, we can choose to hide them. And if we do see something that sets off an alarm, we can then use this scenario as a filter to drill into specific cases where this protocol has been violated. Let's take a quick look at the dashboarding capabilities. As a business manager, you may want to be logging into this tool to do deep analysis. That's what the analyst should be doing. But there may be certain company goals or high-level initiatives which you need to monitor. So we've included the basic dashboard capability for those users, and it's a bit less daunting than the initial timeline view. So the charts on this dashboard are totally interactive and drillable to the extent that you can take a look at the exact timelines which make up a given data set. You also have the ability to easily configure your dashboard. We can change the layout visually or modify any given chart very simply and quickly. Now, keep in mind that this is not a business intelligence dashboard. It's purely a way of surfacing up information that is directly related to the kind of analysis that TimelinePI can do and that you've seen thus far. Another form of specialized analysis is the workflow analysis tool, which can be used for scenarios when you have a large call center. So if you think of a call center's operations, a customer will call in for any number of reasons. They've changed their address, need policy information, they have billing questions, possibly want to submit a claim, and so on. The call comes in and it's routed to a certain queue, and hopefully the request can be fulfilled and closed by that person. Oftentimes that's not the case, and the customer will be routed from one queue to another depending on the complexity of their request. So in this scenario, all we need to do is answer a few simple questions about a call center's operations. First, we'll define how work is started in a queue, then how it's finished, how do we define wait time, And then lastly, where are exceptions occurring? When we're going back to a previous queue after starting work in it, if it contains specific events, or for instance has been routed to a specific queue, which always means this is an error queue. So you simply answer these questions. Once that's done, you'll see a full picture of how customers are interacting and being routed around the call center. So some of the metrics we have here, the first queue where people are most commonly being sent, and then we can compare that with the last queue from their call. This will give us a good indication of how many requests are being fulfilled in a single queue. Now in this example, we can see that policy remediation is the most common last queue in a call, but it shows as just a small sliver of the first queue that customers are routed to. This may signal something like an issue with the automated system if it is consistently sending people to the wrong queue. They're consistently finishing in a policy remediation. We can also see metrics around the queues per timeline, time spent in queues, work time versus wait time, the throughput of calls through queues, and then also queue aging, the next and previous, and the exceptions in the queue. So I'd venture to say that the timeline with the smallest amount of queues and wait time before closing out a customer request would result in a happier customer. The overall point here is that the tool can automatically bring up this type of analysis, whereas customers typically have no other way to tie together the entire customer journey throughout their call center.